Hello! So, we're going to continue with our series on geometry. Geometry. In the last video, we covered the undefined terms as in points, lines, and planes. So now we're going to cover the next thing, segments and rays. Segments and rays. Okay, what are segments and rays? So let's first start off with number one, with how they form, which is a line. Let's have a very big line. This very big line. Let's call it point A, B. So this is line AB. Okay? So line AB, we can write it like line AB. Okay. So now what we do, how do we make a ray? Let's start off with the ray first, because the ray is easier. So let's put another point C in the middle, okay? Between line A and B. So now what will we call CB? CB extends forever in one direction, instead of the lines two, because we cut it in half. Meaning it will go forever in only one direction. So yeah, it can go forever in one direction. These are called rays. Like a beam of light. The beam of light will go like in one direction. So rays can only go in the specific direction, in one direction, forever. Specific direction. Okay. Let's cover a notation of how you write a ray. So let's say we have two rays. Just down the line, let's call them what we did before. We have our AB and our BC. AB and then our ray CB. So how will we notate it? So let's start with the 2 points that will constitute our ray, C and B. Okay, then what's the symbol we put on the top? Well, yeah, we put this. This is our symbol. It's a ray. But then there's a very important thing here. Okay, this is important. Important. It's that the ray symbol on the top changes depending on the direction. Let's look at another example. Ray CA. Well, this ray is going this way, so then the symbol goes this way. And also another important thing is that rays are labeled with the endpoint first. So as in, this is our endpoint. If we were to draw CB without its line and have an endpoint of C where it stopped, this is called an endpoint. Endpoint. So a quick recap. What is a ray? A ray is formed with an endpoint and then one part extending in one direction, like a flashlight ray. And it's notated with the endpoint first, then another point to constitute it, with a ray symbol on the top that changes depending on its direction. Okay. So the examples we've been using is a thing called, opposite rays. This is a type of ray that's kind of important. Why is it important? So we've been using our example with the line AB. Line AB. With C in the middle. Okay? Right? Yeah. So this is considered a pair of opposite rays. Why? Because this is originally a line AB, which was split by point C. Meaning these two rays are going in opposite directions. One's going left and one's going right, which are opposite directions, which is why they're called opposite rays. And they also have the same endpoint, because they're opposite of each other. So, like your two hands, if you stretch them out, you can say that your shoulders and your collar are the endpoint, and then your hands are the rays, the opposite rays. So you can say that ray AC plus the ray, I read it wrong. Ray CA plus ray CB will equal to line AB. We'll get more onto that when we learn about a different postulate. Okay. Now we're going to talk about segments. So segments, instead of 1 point with our line, let's call this line a different name. Let's call it EF. EF, and we have a point G in the middle. Actually, no, not point G. Sorry. So we have a point G. Okay, let's say we have a point G. So let's say we have E and G. Anything between E and G. Just that, okay? Anything between E and G. These are 2 points connected. No, going on forever. It has a finite length, which can tell you it's a segment. If it has a finite length, it's a segment. So a segment, unlike rays or lines, have 2 endpoints. Let's see. E and G. So this is a segment with a finite length. We will get into that when we talk about the postulates of segments, that it can be measured and it can be bisected. So a segment has two endpoints and it's finite, as we discussed. And how do we notate it? We can notate it in 2 different ways, like a line, EG or GE. We can go either direction, and the symbol on the top is just a straight line, because that's what it is. It's a line with endpoints. So segments is a part of a line with 2 endpoints, while rays only have 1 endpoint, and it goes on forever in 1 direction. And opposite rays are 2 rays connected by a single endpoint that can form a line. Okay. Okay. So now let's talk about some postulates. More importantly with the segments, because segments have very important postulates with them. Okay. So, one postulate is the ruler postulate. This one has a name. Isn't that kind of cool? It has a name. These important postulates have a name with them. So you don't have to call them by their full title. So a ruler postulate's a ruler postulate. You can imagine it like a ruler. So it's like you're measuring something. So let's say you have this on the number line. We have our 2 points, A and B, and A is on 2 on the number line, and B is on 5 on the number line. So how can we measure what is the distance between A and B? Well, one thing we know is that absolute value is a very good way at measuring distance, because it doesn't matter whether it's negative or positive, it'll just be a distance that's a positive value. So let's take 5 minus 2 to the absolute value, and we get 3 to the absolute value, which is 3. That measures the distance, which is going to be 1, 2, 3, yeah. So if you take the difference between this distance and this distance from this place and this other distance, you can get the total length of the segment, which is very nice. So if you want a formula, which I can give, we have a segment, 2 points, with a measure A and B. Then the length will be B minus A to the absolute value. Okay? We could also do it the other way. So because if we go back to our 5 and 2 example, 2 and 5, it doesn't matter which direction we're going, because if we do it 2 minus 5, we get minus 3. To the absolute value will just be 3, because we're measuring only a distance, and distance can never be negative. Okay? That's the first postulate, which can help you measure stuff, which is probably why it's called the ruler postulate. Used for measuring. Now, using the knowledge we have in our ruler postulate, we can now use this postulate, segment addition. Segment addition. So it sounds like the name, it involves segment and adding. So let's have our situation here. We have our